By the time this lesson is over, I'd like you to remember 3 things, and pay attention to these 3 things because I'm going to ask you and quiz you in a bit on them. The first thing you need to try to remember by the time this lesson is over is what an integer is. You need to define an integer properly. The second thing you're going to have to be very aware of is how to decide, using a number line, which integer is larger and which integer is smaller. So we have 2 things so far. The number 1, what was it? What does an integer mean? A very precise definition as to what an integer is. And the second thing you need to know is how to decide which integer is larger and which is smaller on a number line. And the third thing you're going to have to be able to explain to me is what are opposite integers? That's 3 things you need to remember. Now on here, I've got a blank number line and it asks me to click here first. Click here first. Let's see what's under this. We've got the number 0 and we're putting it in the middle of a number line. It's not always in the middle. We can put it anywhere we want, but in this case, it's in the middle. We're going to have to click this. On a number line, if you go to the left, you're always going to get smaller numbers. Always. If we click this one, if you go the opposite direction, you're going to get larger numbers. Now let's see what the larger numbers are. After 0, we go from 1, 2, 3, 4, all the way to 13 and forever and ever and ever. And we call these positive numbers, and I've made them yellow. Positive numbers are going to be yellow. If we go to the left, we're going to get what's called negative numbers. On the left of 0, we always have the negative numbers sitting down. On a thermometer, you could see negative numbers below the 0. Thermometers stand up and down. Well, on a thermometer, anything below 0 is going to be a negative, sort of like negative temperatures, pretty cold. Now, what are integers? What's the definition of an integer? Integers are non-decimal numbers. That's very important. If I take this number 1, which right now it's an integer, we don't see any decimal, but if I take that number 1 and I write it like this, 1.0, it means the same thing. 1.0 is 1. But this one is an integer and this one is not an integer because we see a decimal value. Now I know some of you are thinking probably that, well, the 1 does have a decimal, but we can't see it. That's exactly right. The decimal is sitting there, but because we can't see it and it's not shown to us, that makes this number an integer. Also, integers are non-fraction numbers. If I write a fraction like 3/4, we don't see any decimal in this number, but it doesn't matter. It's not an integer because integers can't be fractions. This is not an integer and this is not an integer. So the exact definition of an integer is a non-decimal, non-fraction number. That's what it is. They're non-decimals and they're non-fractions. Now we're dealing with integers. They can be positive, they can be negative, they just can't be decimals and they can't be fractions. Now what are opposite integers? -5 and +5. This one here and that one there, they're opposite. -12 and +12 are also opposite integers. -2 and +2 are also opposite integers, and I'll leave the definition up to you and how to explain what opposite integers are. Circle the larger integer. We have -5 and we have 0. Which is larger? The 0 is going to be larger, right? Because it's on the right side. As you go this direction, if you go in this direction, you're always going to get larger numbers. So 0 is going to be larger than -5. It's not going to be -5.
No! No! No!
Listen to the man. It's not -5, it's 0. How about between -10 and -12? Here's -10. Here's -12. Which is larger? It's not -12. It's -10. Which without a number line, if you were just to look at those two numbers, you might accidentally pick -12 as the larger number because 12 is bigger than 10. But once you get to the negatives territory, the numbers don't act really the same way. Now we have -52 and -25. We can't see -52 and we can't see -25. This is an ultimate test on your ability to understand this stuff. Can you understand which is larger without the number line? If you said this one is larger,
No! No! No!
because negative 52 is way down there. Negative 25 is going to be closer to 0. Circle the smaller integer. We have negative 5, we have negative 9, and we have negative 5. Here's negative 9. Here's negative 5. Which one is smaller? Smaller means you need to go that way. So negative 9 is more that way, so it's going to be smaller. It's not negative 5. This one's bigger. This is not smaller. Negative 9 is it. We have negative 3. We have 0, which is smaller. Smaller means go more to the left, so negative 3 is going to be the right answer. It's not 0. Positive 4 or negative 41. Can we see negative 41? No, we can't see it, but we know where it is. It's way down there on the left side. It's way, let me move this arrow. It's way down there. So it's going to be smaller. It's not this.
No! No! No!
Last page. Arrange the following integers in order from greatest integer to least integer. We want the greatest one first and the smallest one last. The greatest one is going to be the furthest number on the positive side to the right. And since we've got positive 7, right? That's the biggest positive number. Not quite. We have 9. But Mr. Melham, 9 doesn't have a positive beside it. Well, neither do any of these, right? If you don't see a symbol beside the number, you assume it's positive. Always. Am I positive about that? You bet I am. Positive 9 is going to be the biggest one. So I'm going to put it right here. Second place is going to be positive 7. Third largest is going to be 0. Because you have positive 9, positive 7, and then we're getting smaller. It's going to be 0 next. And what's after that? Negative 3. We're going to put him beside the 0. And then negative 7. And then negative 9. And negative 50 is really small. If we're dealing with temperatures, negative 50 is freezing cold. In Canada, we deal with Celsius.